chapter 11. Now we're dealing with stoichiometry. You guys are going to love it. All right. Section 1 is defining stoichiometry. So what is this big long word? Anyways, it's studying the relationships between the amounts of reactants used and the amounts of products formed by a chemical reaction. So you could look at any of the reactants and figure out how much product should be formed. You could also look at the products and figure out how many reactants you used. But you could also look at reactants versus reactants. Okay, based on the law of conservation of mass. So the total mass of the reactants is always going to equal the total mass of the products. You guys have known that for a long time.
Let's hope so.
Okay, so when you balance a chemical equation, you use coefficients to balance it. The coefficients can represent the number of particles or the number of moles. Remember, particles could be atoms, molecules, or formula units. So that first equation there, I have it listed: 4 atoms of Fe plus 3 molecules of O2 and 2 formula units of Fe2O3. That's showing you how many particles you have. And then the second one goes through, and the same thing. You can look at the number of moles. So based on the law of conservation of mass, you should have the same amount of products as you do reactants. Okay, so our reactants, we have 4 moles of Fe. We know that the molar mass of Fe is going to be 56 grams per mole because it's 55.8 or something like that. So 4 moles times 56, what is that?
Ugh. I gotta get my calculator, I don't know. 224, you did it in the notes.
I know. I'm nice.
So here we're gonna do the seeing if our reactants and our products are equal, right? Is what we're doing? Okay.
So now we have 3 moles of oxygen gas, but it's O2 because it's diatomic. That's how we get 32.
Okay. 3 times 32 is 96.
Okay, if you add these two together, what's the number that you
224
get?
plus 96 is 320.
Okay, 320 grams for your reactants. You might have to write it in your notes off to the side, or you can do it this way. And then your products, you have 2 moles of iron oxide, and the molar mass is 160. So 2 times 160 gives us
320.
So, based on the law of conservation of mass, our products equal our reactants.
Yay!
Yay. Now, we got to talk about mole ratios. This is the ratio between the number of moles of any 2 of the substances in the balanced chemical equation. So, this is where we see a lot of mistakes. Students don't balance. They forget. They just assume we give them an equation and it's already balanced. That's not true. So, throughout your notes, these are not balanced for a reason. You got to go through so that you remember to always balance it. Sometimes they will be balanced for you, but you always need to double check. Just don't assume that they are. Right. Okay, so we have 2 potassiums and 2 BRs. Or sorry, we have 1 potassium and 2 BRs. I don't know where my pointer is.
So we need 2 potassiums.
Okay.
There you are.
So we need 2. Whoa, there we go. And 2 here. That's a 2. Okay, so then you can find all of the mole ratios. So this is annoying. However, this is how it goes. You have 2 potassiums to 1 BR2.
Yep, then you got to compare it to the product, 2 potassium to 2 KBr. Then you switch it. So now Br is going to go first, so it's 1 BR2 to 2 Ks, 1 BR2 to 2 KBRs. Then you get your potassium bromide that gets to go first, so 2 KBr to 2 Ks and 2 KBRs to 1 bromine. That's mole ratios. It's how you compare everything to each other.
So when we ask you for mole ratios, we're asking you not for 1. Notice this one has 6 mole ratios. Okay, that's what we're asking you for, is go through each one and make sure it pairs up with something else in the equation. Okay? Let's do one more.
Oh, yay.
Balance, you have, what would that be? Potassium chlorate?
Yeah, so we got K is 1 and K is 1, Cl is 1 and Cl is 1, but those darn oxygens are not right. So common factor is going to be a 6, so a 3 and a 2, which changes our KCl to a 2, so we have 2, 2, 3.
Okay, so I'm going to go through
KClO3
to our mole ratios.
Yay!
Where again we're going to have 6 because we have 3 formulas here.
Well, while she's doing that, let me just kind of tell you how you can easily figure out how many ratios you're going to have. So you add up how many different molecules, atoms, or formula units you have within the equation. Here we have 3 of them. We've got the potassium chlorate, the potassium chloride, and the oxygen gas. Those are 3 of them, and then you would take that number of the total and multiply it by one number less. That gives you 6. If you had 4 different things in your chemical equation and you wanted to figure out how many more ratios total you would need to write out, you would have 4 times 3, because that's one number less than your total, and you would have 12 more ratios that you would need to be writing out.
Yes, and that is in your book.
Mhm.
If you didn't follow that.
Or we'll tell you more in class.
Yes. Okay, that's section 1.
Yay!